Right, and we are live. Welcome everyone to Change Notice. We're going to wait just a few minutes for everyone to file in, but I'm super excited. This is VR edition. VR is all the rage. Everyone's stuck in metaverse. And before we do introductions, let's just talk about what everyone's experience with VR is. So while we're waiting, you'll see the little chat down at the bottom. Go ahead, introduce yourself, and let us know what was your first ever VR experience, first ever. And make sure you're chatting to everyone and not just hosts and panelists. That's a little trick that Zoom likes to play. So joined here by Chris and Molly. Let's start with Chris. What was your first VR experience?
Yeah, actually, well, I'll have two. One is, even though it's the first experience, the first one, I went to get an early demo of the Oculus system when they were still kind of building it. Maybe they released the Rift, but they were working on the first Quest. And I remember being really blown away by how incredible, incredibly immersive it was. But the time when I really actually started to do more with it was my wife. During the pandemic, her company sent them VR headsets to have a virtual holiday party. And it was so hilarious to watch her navigate around and try to meet her coworkers. She has coworkers in foreign countries, and they were all together in the metaverse, basically. So that was my first experience, really seeing people work with that. How about you, Molly?
That's awesome. Yeah, what about you, Molly?
That is awesome. Yeah, I think for me, I'm thinking it's around 2017, right around the time I joined at Google. We had an offsite, and they had a booth there at this outside of this bowling alley where they had some Google Cardboard. So this was where you put your phone inside. And that was, yeah, I think that was my first experience. More recently, played some Beat Saber on the Quest 2. Definitely a fun time. So yeah, what about you, Tobias?
Yeah, that's funny. My very first one was actually similar. It wasn't quite as early back. I see Joe got a demo at NASA in the 90s. Wow, that's throwing it back. Wow. That's awesome. For everyone just joining us, we're talking about our first VR experience. Mine was also I think it was a cardboard cutout. Maybe it was Google Cardboard. And it was at this van that was parked that was promoting their VR system, but they wanted to demo with just this little cardboard. And so you folded it up, you put your iPhone in, and it was actually not as horrible as I thought, because it actually used the Excel and the gyro, and you could move your head around. I think you were flying through space was the demo. And so that was kind of my very first VR experience. Yeah, and then since then, a little bit of Oculus here and there. So,
oh man, we even have a late 80s demo.
Oh wow! Well, now it's like a competition about who experienced VR first. All right, lots of cardboard cutouts. So it's great to know that was everyone's first delve into VR. All right, let's go ahead and kick this off. So welcome everyone to Change Notice Unsnapped. This is our monthly live teardown webinar where we take stuff apart and we talk shop with engineers and other tinkers like yourself. So super excited for today. For anyone just joining us, please introduce yourself down in the chat. Make sure you're chatting to everyone, not just the panelists. Introduce yourself and tell us about your first ever VR experience. And our goal here today with these teardowns, we're really trying to build a community for knowledge sharing, support, and continuous improvements. And a few reminders here: if you do need to duck out early, please fill out that survey at the end. That's how we improve for next time. That's how we pick the next product. And a few other reminders: we're going to do introductions, we'll go through the agenda. Please ask questions throughout the entire teardown. That's why we're here, to have a discussion. And as you're sharing, I love these stories about the first the first VR headsets. If any of you guys have ever worked either as a design engineer or on the product team for any VR headset, we'd love to hear your experience as well. Sometimes on these teardowns, we actually get experts from these device categories or people that have worked on devices to share their expert knowledge with us. So without further ado, let's introduce the team and then dive into the teardown. So joined here by Chris and Molly. Chris, you want to start us off?
Yeah, hey guys, I'm Chris. I used to work at Amazon on a bunch of Kindle products, and then I went to a small health tech startup, and most recently, right now, I'm at a ag tech startup doing self-driving autonomous tractors. So, going from consumer electronics to healthcare to ag tech, very interesting. How about you, Molly?
Hey, I'm Molly. I'm a solutions architect here at Instrumental. Been here for about a year now, so I help with the technical scoping and implementation, just be kind of a general mechanical engineering resource for our customers. Before this, I was working at Google on laptops and tablets as a product design engineer. And previous to that, kind of working on a slew of different consumer electronics, robotics kind of projects at Function Engineering.
All right. Welcome. Yeah, Molly, this is first time special guest Molly joining the teardown crew. So I'm Tobias. My background's in mechanical engineering. I did product design back at Apple for about 6 years, working on Apple Watch, health sensors, iPhone touchscreens, and now I lead our partnerships at Instrumental. So super excited. Let's dive into this teardown here. Thank you everyone for sharing some of your background here. Welcome back to the regulars too. I see some familiar names. I always like to hear as well, if you want to post in, if you've been to one of these teardowns before, let us know which one you've been to, which one was your favorite. And while we're queuing that up, let's dive in. We're going to go through, Chris is going to go through the live teardown. We'll have Q&A at the end, but please just ask any questions throughout because that'll help guide where we focus some of the discussion. Let's, while Chris is kind of kicking us off here, maybe let's talk about why we picked the VR headset, like why VR? Molly, you want to share?
Sure. I think metaverse is something that's on everyone's minds right now. We're getting a lot of incoming news from Meta itself and from other companies trying to get into this VR space. So it seems really exciting. It's kind of exciting to see who's going to get there first and build out a platform that people are really excited about. Also, this VR headset kind of product is actually a really great product for Instrumental. This is like, super complex. There's a lot going on, a lot of areas where we would help someone as a customer. So I think we just thought, and besides that, we also got a lot of requests previously for this one to be the next teardown. So we're listening and excited to tear this down with you guys.
Yeah. So here is the HP Reverb. I think this is the G2, and this is a second version of the G2. They recently released one, which I think you can tell the difference because there's a separate this eyepiece that comes out. The gasket has two pieces, so you can get either a closer field of view, or if you have glasses, I think this separates your face a little bit further away from, or your lenses away from their lenses, which can scratch a little bit pretty easily. So that's pretty interesting. But yeah, the headset basically has a main module, a couple of speakers on the side, which are adjustable. And then there's a bunch of, I'm trying to turn this here. There's 4 cameras on here. So that once you're in the system, if you're getting too close to the wall or something else, it can tell you where you are in space. There are 2 separate lenses. I think we're talking about the Google Cardboard where you're using your phone, which is just kind of one screen, but these actually have 2 separate lenses. And one of the cool things about this one is it kind of adjusts in and out. So you can set that to where your interpupillary distance is, or basically the distance between your eyes. So let's go ahead and get started in here. I'm gonna unscrew the first Actually, I think it's 4 or 8 screws here. Let it go in.
I do like, compared to the Oculus Quest here, the speakers I think are really, they're going to be a lot closer to people's ears, and they're also adjustable. And so I think they're kind of emphasizing a really good audio experience through the VR experience.
Yeah. I think
the Oculus ones are built into the head strap, I think, correct?
That's right. Yep.
Yeah, and I think why do you think they did that? Is that to keep costs down, or is that something that they got to have more mechanical systems and more things, maybe reliability or something like that?
Yeah, I thought it was really about having a really great audio experience. I can't imagine it would be, less costly to do it this way with the adjustability. So I think that must have been a key piece that they wanted to emphasize here.
I'm seeing a lot of VR experts in the audience here, either having experience developing in VR or even some folks that worked on VR products. So I'm excited as we speculate about some of the design here. Maybe they'll be able to tell us if any of our theories are correct or if we're just way off track here.
So I'm just basically, go ahead.
Yeah, it looks like, Chris, you had how many screws that were holding on that front plate?
I had 4 from the back, and they were pretty deep screws, so I needed to cheat on my my iFixit kit for a bit and use a long screwdriver. But there's 4 screws that held the front plate in, and then I just a bunch of snaps around the corner, around the outside, the perimeter. So I used these guitar picks, and if I just flip this up, we got a view of the main PC board here, which looks like a lot of flex cables, some cameras, some other things. I think it's a little hard to see this while I'm holding it and moving it. Maybe it'd be a good time to switch over to instrumental.
Yeah, let's look at some high-res images. I think you're going to have to stop sharing there, Chris. And let me pull this up. So here we are looking at the instrumental application. This is our web app. For those of you familiar, you probably already know what's going on here. But for the newcomers, what our platform does is we help to accelerate product development in NPI, as well as in mass production, to improve product quality, improve yield. And what our platform leverages is image data, like the images that you're seeing here, as well as test data. We help to correlate, accelerate failure analysis. And so we can tell you all about the full platform if you're interested. What we're looking at right here is mostly just images. So we're using just a tiny portion of the platform to easily navigate some of these high resolution images. So you can see we've got all the finished good images here at the end. And right now we're looking at this main PCB, and there's a lot of stuff going on here. This is going to be fun. The first thing that I see here, I see a lot of ZIF connectors, both around the edges, looks like for the cameras here, a couple mic cables, and then down at the bottom, these are two interesting connectors. Yeah, when I first saw these, I was a little bit puzzled what this additional little piece of tape is, and also what this little white almost looks like a hole in the top on these 2 connectors. So I think these are the speaker cables. I'd like to hear from the audience. What do you guys think is going on with what looks like capped on tape and a hole here? What do you think the purpose, the design intent for this connector? Maybe Chris or Molly, do you guys have thoughts on what this could be?
Yeah, my first thought, and I don't know, I'm curious to hear other people's theories too, but my first thought is that they're kind of checking to make sure that that connector is all the way in. Kind of basically they've made a sort of window in to see that white piece of the housing of the cable, and and this could be a check. I do see there's also the silkscreen printing line, which is, so either this was a really, for whatever reason, really hard to make sure that connection was fully made, or maybe something else. What do you think, Chris?
Yeah, that's a good question. I mean, I think you're right. They do have that line there, and if this was a problem and they needed to guarantee that those things were checked, that secondary window would be good, and maybe something where instrumental could help, and you could have a record of every single device that went through, and you could see, are these actually in there? But in my experience, I've actually had something similar to this where because that hole is basically very close to the center of mass of the connector. So when you're doing a pick and place machine, then the little nozzle comes and like tries to suck up the connector. If there's a hole in there, it can't suck it up. So it could be that they had to put a piece of Kapton tape on there to cover the center mass so that the pick and place machine could get it.
That makes a lot of sense. Yeah.
that one's really interesting. I wouldn't have guessed the pick and place. My initial thought was more around the connector insertion too, which is interesting that they have a twofold method, both the line and the hole, which to me indicates there might have been some challenges. I know a lot of our customers have struggled with this. Specifically, I remember one of our large electronic customers was leveraging instrumental to have the data record of the connectors, because when they were going through reliability tests, some of the connectors were popping out. They would come loose, and then they would have no idea if it was a design issue with the connector or if the connector was not fully inserted at the initial assembly. So they leveraged instrumental to go back to that data record and really pinpoint, like, oh yes, these 4 connectors, they were actually partially inserted, process issue, to really root cause that. Let's talk about, there's a couple other really interesting things. There's this giant foam here, which it's not fully represented, but if you look at it in real life, that's a pretty tall foam. And it looks like it's contacting this front plate here. I'm not exactly sure from this view what this foam's design purpose is. So again, going to go to the audience here, and we'll investigate this more later. What do you think this kind of L-shaped tall foam is doing on the PCB here? Any ideas on the foam?
I'll add that it's not symmetric, right? So that's kind of interesting.
And you can't really see in here, but it is quite tall. It's actually standing off, I don't know, maybe like a centimeter or so. So it's actually pretty high off, and it could be that the whatever it's compressing, the shape of the reverb actually is pretty rounded up there. So maybe it has to make quite a distance, but it could also just need to be in that much compression.
Looks like we got one hypothesis here from Richard: physical stability for shock or vibration. That's an interesting one. I do wonder, to Molly's point, it's not symmetric. There's no foam on the other side. If it was really for full stability, I would expect multiple foams to really lock the PCB in place. So the kind of odd question is, why is there a foam just on this one side when it seems like we have a good amount of fasteners, screws holding this into the chassis? But maybe. Question from Charles: is it soft or firm? I can hold it up here. I would say, I don't have my durometer tester right here, but it's overall it's pretty soft. So it's definitely compressible. I can pretty easily compress it to about 50% of its height. Victor also guessing for rattle found in testing. That's an interesting one. We're going to talk about that in a second, actually. Rattle, Victor, are you thinking like rattle of the PCB or rattle of some other components? Because they're different problems. But I like the thoughts. Let's see what other interesting tidbits we can find. This one to me is interesting. This kind of the side curvature of this camera flex, which I think, Molly and Chris, what do you think is underneath here? What kind of connector is underneath here?
I'm gonna guess board to
go
board,
ahead.
I think.
Yeah,
Yeah.
I would agree. I think if you're trying to hold it down with a bracket over it, actually where I've seen this a lot is in iPhone products where they're very limited in Z space, where they're trying to hold something down without too much distance, behind it. But yeah, I would say suspect a board to board.
Yeah, that's an interesting one. But it's board to board plus this fastener on top, plus this cowling, which means that either they want to be extra sure that that doesn't pop off during drop or vibe, or potentially they had some issues because of the way that loop folds. There may be some residual kind of stress or strain wanting to pull that board to board off. That's my hypothesis here, just looking at that.
Yeah, and it's kind of interesting how the cameras are kind of at a little bit of an angle just to get out, and so they must, the flex looks like it's relatively straight, but maybe they needed something that there was a little bit of tension on that as it's wrapped around.
What about this? What appears to be the mic cables? We've got two mic cables here plugged into some small ZIF connectors. What surprised me is what looks like some pretty heavy shielding going on around the flex. It looks like it's almost a standard FPC surrounded by some type of conductive material, which I'm assuming is for some type of RF shielding, which is really interesting on the mic signals. That wouldn't be my first thought. Do you guys have any other thoughts, or from the audience here, why do you think there's this conductive shielding around both of these mic cables?
Yeah, that's an interesting one, Molly. I don't know if you have any thoughts. I was thinking it could be both for shielding, maybe the camera signals are pretty noisy and it could interfere with the mics, or maybe they just needed some kind of shielding for mechanical rub to if the mic cables were getting torn or something during assembly or use. But yeah, what do you think, Molly?
Yeah, I think I'm thinking along the same lines. Than maybe the camera cables being noisy. Yeah, that's all I've got for that one.
I do like, as a side note, most of these ZIF connectors here have this additional tab layer, which make it a lot easier to actually insert and remove compared to a lot of the other devices that we tear down. It's just the FPC that routes up there, that 180-degree loop, and then they rely on the operators with tweezers to insert that, which makes it much more difficult, much higher chance of a crooked ZIF that's going to pop out later. So I think this was a solid design choice. Probably makes repairability a little bit easier as well, because you're able to take it in and out.
Yeah, I also like the lines on the flex cables. They really show you how far in those need to go. So like to Molly's point earlier about the speaker cables had the line, and these camera cables and LCD cables have a line too. And they even mark pin 1 so you can't get it backwards. It's, everything here is they've done a pretty solid job on making this foolproof, or as manufacturing friendly as possible.
All right, completing our circle here. I see down at the bottom, looks like we have a coax connector, likely an antenna cable. I'm thinking Bluetooth antenna for the controllers is my first guess there. And what's interesting, which we can talk about for a second, this appears to be a piece of tape here that's connecting the speaker cable, which kind of routes through here. I'm not quite sure the purpose of this tape. I don't think it's grounding. Again, from the audience, any experts in the audience want to share their insights on this tape here? We see it over on the other side as well. Molly, do you have any ideas what this tape could be for?
Yeah, having worked on some speakers, I'm gonna guess this is kind of a rub and buzz mitigation. We can see that it seems like the routing is pretty particular through this area, and maybe they found that, you know, the cable was actually contributing to some rub and buzz distortion on the speaker quality. So that's my best guess. This is actually the kind of thing that you know, as someone who spent many hours, unfortunately, in a lab trying to figure out the root cause for rub and buzz issues, I am very jealous of our current customers who get to use instrumental correlations, which basically, you know, you can see your functional test results like rub and buzz. You can basically just click into it and see where you have correlations to other data. But like in this case, you might be able to see that, you know, when this tape is in place, we don't see those kind of failures in the rub and buzz, and when the tape is not there, then we do. And just highlight that really quickly. So much better than the old fashioned way I used to use, and kind of hitting my head against a wall in the lab, trying tiny little differences and seeing if it made any change on one unit at a time.
Yeah, I can't count the number of customers that have had rub and buzz issues. It seems to be like a consistent struggle with many of the customers that we work with.
Yep, it's a really tough one.
All right, let's keep moving here. I know this was a jam-packed PCB. It looks like in the comments here, some of our experts, looks like Adolfo is confirming Richard is the winner here, that it helps to mitigate some of the squishiness and the vibration that occurs during manufacturing variability. So looks like a winner there, that there could be some vibration either on the front plate or the PCB, and this just helps to kind of take up that gap. And another winner from Molly on the cable here, that these are routing improvements that were made on the speaker cable. Excellent. The
Great
last
to
thing
get this validation. I love it.
The last thing that I'm personally curious on is looking at these pads here, where it looks like there used to be a sensor that was SMT, just looking from the silk screen, that's no longer stuffed in this PCB. And my only thoughts here are, I know Chris, you mentioned this is actually the second version of the G2, and I'm wondering if there was, I've seen this in other devices when there's a rev, there's like a PRQ where they actually change the design just a little bit, and they don't want to reroute the board, so they actually leave in these pads, but for some design reason they don't actually need that sensor. But I'm curious what that additional sensor would have been on the front here that they were actually able to remove but still keep all the functionality. So again, now accepting guesses in the chat on what sensor. I love that we have experts that can actually guide us and answer some of our questions here.
Oh, there's a hint already. Maybe there was a higher end version or something where
different SKUs. That makes sense. There's different SKUs, but they want to use the same core PCB and just stuff different sensors.
Yeah, it's interesting. You can see the lines coming from looks like the antenna or whatever region next to it, and out of that into the sensor, and then out of that sensor to the main shielded region as well. So there must have been something maybe to do with some kind of antenna performance or something like that as well, that need to go directly into the main CPU. But yeah.
All right. Let's hop back to tear down the rest of this device here and keep looking. There's just a lot of stuff going on here. And again, those of you joining us, let us know what components you're most interested in, and we can go down that path. We can tear down specific components that you want to learn more about.
So while Tobias and Molly were sharing the instrumental platform, I actually took out 4, or actually 8 screws. So 4 from the front in these, I can't bend it that way, in these holes here. And then I took 4 from the back, which were actually serve double duty. One to hold this bracket down, or this this sensor, this cover down, but also serve as like the magnetic attach points for the eye gasket, which is pretty cool. So if I take this out, it looks like I have to unsnap. There's a proximity sensor or some kind of sensor here. So if I can unsnap that, maybe I can pull this out now. So I take that out, and there looks like there's some kind of prox sensor or sensor there. So you can, there's a window here, so you know when it's coming to your face, and you can turn the LCDs on. And then immediately, boom, we see the lenses, which is pretty cool. You can see there's like a rack and pinion or some kind of gear in the middle there. And now that I've got this here, I think I can take off you can see where the speaker wires route a little bit through here, one on that side and one on this side. Now I'm going to try to bend these cables, see if I can get this into this.
I know there was a question earlier on that I want to make sure we address. Someone was asking about how did we pick this specific VR headset, the HP Reverb, because again, there's a lot of top headsets these days, and it was actually a couple things. Number one, we actually work with a couple different VR companies, and when we have customers, we typically don't tear down their products. So we had some constraints there on people that we're already working with at Instrumental. And honestly, we hadn't seen, it looked like a really interesting design, and I hadn't seen a whole lot of other teardowns of this device. So it felt like something new where we could contribute to the community here. So that was kind of how we landed on the HP one.
I'm going to take out these antenna cables as well.
So it looks like, Chris, so we have the PCB, and it almost looks like there's an entire module in there that you're going to be able to take out. The PCB is attached to what looks like a frame or a chassis. And then, oh yeah, there you go.
I think I've got most of it out. Let's see what is stuck. Oh, it's one of those tapes, I think. Oh, I think it's the microphones. Let me take those out. Yep, there you go. Yeah, okay, so I got a frame that holds the main LCDs with their lenses, and I got the cameras. I got almost everything except I think the microphones here and the speakers, which I had to take out, and the prox sensor. But yeah, this is a pretty cool little module here. Trying to think what the next steps would be. I can take off some of these things, and we can lift out the boards. Let me remove these very handy pull tabs for the main LCD sensors.
We should look at too, I always like looking at the actual mechanical actuation, because again, that's always one of the trickiest parts, when you're designing phones and stuff. Sure. There's very few moving parts, but here we actually have, how does that mechanism work? The interpupillary distance adjustment.
Yeah, so there's so I did cheat earlier. There's also a little button here that locks this whole thing in place. And when I was taking it apart the first time, I couldn't figure out how to open this. But once you take that out, then this whole thing does slide out. And by moving this, it's a very smooth mechanism. But if you move it back and forth, you can kind of see it here. It just shifts the two spacers apart, or the two LCDs apart. And now that I've moved it apart, you can see the gear inside, as well as some plastic, I guess, racks on the other side. And then there are these two very small like metal rails here and here, which the two lenses slide across. So a really cool design. And when you do that, you can see the cable actually moves as well. This cable here.
Oh, so they had enough of
so they have to have a little bit of slack in there. There's plenty of clearance in their frame here. The other thing, this frame looks, kind of familiar. Not quite sure. Maybe I suspect it might be maybe magnesium. I don't know, Molly. Maybe you can tell us a little bit more about what you're seeing here on this.
Yeah, I also think this is magnesium.
Okay.
I have I wouldn't recommend doing cosmetic magnesium parts to my worst enemy. Spent too much time working on that. But in general, I think internal magnesium parts are great like this. It's got a really great strength to weight ratio, which, obviously is a huge reason to use it. Cost is also pretty good. Yeah, my issues with it were more around the low surface energy. So adhesion can be really hard. So especially, cosmetic parts, we were trying to paint ours. Getting that paint to stay on the mag in a reliable way was really hard. But here, I would say overall, actually, there's not a ton of PSA in this product. And I would say kudos to the HP design team for creating something that's pretty disassemblable and reassemblable too. So that's awesome. I imagine they would get a good iFixit score here.
Yeah, we're channeling our partners at our iFixit, even though they're not here to join us today. But yeah, overall, it looks like Chris was able to pop it apart with just some standard screwdrivers, some plastic picks, and no glue surprises, which is always nice.
Yeah. Let's see. All right, now I gotta take off, I think, these screws, which again, you can see these little triangles indicating kind of where to screw because they have a few extra holes here, and I think it's great. Really helping everybody figure out how to take this apart. So let me take this off.
The silk screen labeled of all the connectors is a nice design touch where it labels the mic cable, the speaker cable, the sensor. That's something that we never had when I was back at Apple on iPhones or watches.
And this handy mat here that we got from iFixit is really great when you have a magnetic screw, but I seem to have lost ones because I didn't have, my screwdriver wasn't magnetized. So I'm switching to my other screwdriver.
Yeah, one thing that we did at Google, at least on laptops, was color coding our screws. So that would be kind of the next step here, right? Is I see it looks like mostly black screws. So the different screws would be color coded, and it was pretty obvious to see when the wrong screw is in the wrong place.
That's next level.
All right. Oh, I got one more. I think this is under that void sticker. So I think my warranty is voided now.
It's official. I'm curious as well from the experts in the audience that have some experience with this product. What were some of the most difficult parts in bringing this to market? We're speculating around rub and buzz on the speaker and connectors and service loops and the design of the mag frame. Is there anything else that we haven't hit on that was kind of a key design insight or challenge that you guys had to overcome? I'd love to know about that.
Yeah, so okay, I got the backs, or I got the board off and kind of on the other side of that foam, which here you can see how tall it is again. There is some kind of interesting Kapton tape and some conductive stuff here. We'll take a look maybe closer on the mag on the on instrumental, because that'll be interesting to see. Is there anything else anyone wants to see on the live part here? Otherwise, I think we can switch back to instrumental. We can take a deeper dive into some of these components.
Yeah, let's take a look. That mag frame is actually reminding me of something for any of those that were with us last time on our Nintendo Switch teardown. We've actually got the whole library of all the other teardowns that we've done, which is really fun. So if any of you guys want to get access, actually we can make that happen. So you too can browse through all of these images. But the Nintendo Switch, I believe this was also a mag frame. Wasn't it, Chris? This was
I think so, yeah.
This was like the main chassis of the Nintendo Switch. Again, they were probably optimizing for strength and weight, similar sort of handheld. But yeah, I've seen it more and more in these handheld devices.
Yeah, I think if you think about a VR headset, it's hitting on your head the whole time. So probably one of the big considerations is weight, just so you don't want to have too much sitting on there, especially if you're in an immersive game for, I don't know, like 4 hours playing this. So I think mag makes a good choice. It's a good choice from the HP team here.
So let's keep moving and look at, so this is where we're at with the chassis and the lenses here. You can see, we'll see a little more later in this little gear mechanism, which is pretty cool, which again adjusts the I'm just going to call it the IPD, the interpupillary distance, the IPD here, and we can talk more about the lenses later. But I want to speculate for a minute on what Chris found here. So on the back side of this PCB, it looks like there is 3 layers here. I think there's a Kapton tape, which is covering a lot of the SMT components, and then what appears to be some type of conductive mesh, and then yet another foam on top of this here. So this is an interesting triple stack. And I'd like to hear from everyone joining us here. What do you think the design intent was of each of these layers? Kapton, which is typically an insulating layer. Conductive foam, first thing that comes to mind is I want to ground something. I either want to shield something from RF signals or I want to ground something. And then another little foam stack on top. Anyone have thoughts? Chris or Molly, you guys have thoughts on what this could be?
Well, I see in the chat that thermal management influences a lot of the design. And I wonder if that's what's going on here. Like, is there maybe a small window in the Kapton? They're trying to pull heat out of some component there.
That's a good thought. I do see on mine that there is a large piece of looks like a conductive pad, thermal pad, basically sitting between those two things, and maybe that Kapton tape is hiding. Actually. We were talking, I think in the chat, there are some lines here. There are some lines that define where the Kapton tape might need to go. That white line on the bottom, there's a corner, and then white line on the right. So yeah, maybe they're lining up specially for this so that they can know where to put the conductive foam and fabric.
And it looks like, so when we take that off here, you can see right underneath, this is the next step. Looks like underneath is the Synaptics chip, which I believe is a display driver. Is that right? I believe Synaptics does touch and display. So I would assume this is the display driver. And so it could be a combination. Again, the display driver could be sensitive to RF interference. So it could either be, those are my top guesses here, either thermal management, like you guys mentioned, or some type of RF shielding from this conductive foam here. Another good guess, ESD protection. Oh, that's interesting. Which side is this on? This is on the inside that's touching the frame. Typically, it's possible that there could be some ESD concerns. Typically, ESD, I guess ESD is kind of black magic as well, because if it zaps part of your device, I remember some ESD, some chaos on the watch where, like, if it zaps, it would kill one of the pixels in the display on the side. But I guess there could be a route where this chip is at risk because it's the lowest impedance path for the ESD to go through. So maybe this shields it in some way. Let's another couple. Oh, Marco was saying a lot of high-speed video in that area. Yes, which could be very sensitive as well.
There's the yeah, it looks like the display port is right over there, and I think did you guys actually use this device right before you took it apart? So it sounds like there's a very intense display or communication coming from the computer and into this. So maybe there's something, a lot of high switching. When you took that, if you go to the next image, there's a lot of very thick like wires coming from the in the layers of the board coming from that chip too. You can see the big routes.
Yeah, this is interesting here too. Whatever these components are that look to be between the display driver and the display port.
Yep.
Looks like another comment from Justin. I think there may have violated minimum electrical distance and needed shielding while maintaining the small form factor. So also speculating. So yeah, it could be shielding. Again, traditional shielding, you might put a shield can over that to do RF shielding. So this could have been a late design decision where they needed to put in a mitigation. Yeah,
and because it's facing the mag frame, you'd think maybe there's enough shielding or like a insulator from the rest of from the outside world, but maybe from some components inside they needed some distance, right? Because this is right against the mag frame, and you can get that big conductive pad right next to it. So I think that works. Oh, there you go.
Yeah, and I think it is contacting this thermal pad, like you said. So yeah. It seems like maybe there's a combination of design intents here, both thermal and RF shielding. So let's keep moving. Unless there's anything else from the audience, anything you guys want us to look into on these PCBs, let us know as we keep going here. There's a few more exciting steps. We want to get to the lens assembly too, because that one's really neat. So let's flip back to Chris and see if we can get that lens off.
Yep, here we go. So again, I cheated a little bit, but basically there's these two rails that we talked about. So if I just take them out, so I pulled them partly out, and I think this whole, I gotta take the sensors through the front. There we go. So they come out in two separate pieces, and here you can see those little like kind of gear teeth or rack teeth that go against this pretty large sort of half moon shape here. So there's the way they translate this motion from the I guess the little mechanical button, and then this moves to the center gear here, which then sits against this. So this can move back and forth. So you get it's a limited amount of travel, but it's it's not insignificant for getting that interpupillary distance, the IPD, correct. If I look at the whole thing again, this is a little hard to see from here, but there are a couple of different. Looks like there's one main cable in. There's another cable that looks like it uses a little ZIF connector. And then there's another connector here as well. So I'm not quite sure what's going on there. Maybe we can take a look at this again if you're able to see this more in depth.
Yeah, let's dive in. And I'm also seeing on the frame and the gear there, it almost looks like, if we take a closer look here, is this grease, or what is this additional color and residue on here?
Yeah, it does look like grease in here. And that must be why you get that kind of smooth feeling without rubbing against the mag frame, which you don't really want to rub against mag because it's a kind of passivated or coated. So you would be exposing that to the elements. So maybe that's to keep that away.
Yeah, I think so. The whole device, I would say, felt really premium when you're using it. Like that sliding feature, and also just everything felt really solid in a nice way.
Yeah, I agree as well. I was also looking at a couple of the molding decisions here. Seems like they're definitely optimizing for strength and weight with the structure that they have throughout here. And I'm not sure if I have a picture, but on the inside of the front cap as well, that plastic molded part, also you could tell that they put a lot of design time into optimizing the thinnest wall while still having that lattice structure to support the strength.
Yep.
All right, so we're looking at the lens, and we also have a little bit of confirmation on our last speculation here. Coming in to save the day, thank you to Adolfo. So Kapton was used as the insulator, and the conductive tape is used as an EM shield over the DDIC. Interesting. So the problem that you were solving was the interference, and but you had to put the Kapton tape underneath it, of course, so you're not just shorting everything out. It's close to the Oculink connector, helps protect against EM interference, and doubling down to take some of the heat and sink that away from the DDIC. All right, and hence the thermal. All right, so we were pretty close, team. Nice job. Double. That's a pretty clever kind of dual design, both for EM shielding as well as thermal management. I like it. All right, let's see. We've got just 10 minutes left here. So if there's anything specific you guys want us to look at, let us know now as we're diving into this lens. So we've got a couple components here. We've got the actual lens portion, which we can talk about, and then the back side, which is really interesting. It's kind of a maze of different connectors to get this service loop that we need. The first thing that I'd like to figure out, so it looks like, I believe this is a LCD display on the other side. Is that right?
Yes. And I think it goes into the lens.
So that folds around.
Yep. And
then it almost looks like, when I first looked at this, these interesting transitions here. Do you guys think, was this two flexes here? I almost thought this might have been like hotbarred together, but it's a little bit hard to tell. What do you guys think?
Yeah, it definitely looks like two, but I think in actually holding that part, it felt like it might just be one single flex.
I think what I'm looking at, there is something on top, but there are those little components there. So I think there's like a little, either a piece of tape or some kind of fit, like a potting material that kind of goes over that to insulate those, because this is also sitting right against the mag frame. So maybe that's what we're seeing.
Yeah, I think you're right. I think I might have been just assuming. I know in a lot of the phones, the display wraps around and then they hotbar onto it. But it looks like here, maybe they were able to make the entire flex into one. And this could just be a cover lay transition here. Mm-hmm. And then this might be a piece of tape shielding some components here. Tapes are always tricky. We can talk about tapes it looks like most of these tapes are kind of well thought out, and they even had the silk screen to designate where the tape is, which that's a great move, because we've worked with so many customers where the tapes are manually applied. Manual processes have huge amounts of variation, and there's really no guarantee that it's put in the right spot, and no record later on too. So we've had many partners and customers at Instrumental where they go back and use the images to determine, oh, was this failure caused by a shift in the tape? You know, the tape wasn't fully covering these small passives over here, and then that led to some interference or some shorting later on. So tapes, it's the bane of all PD engineers. But also very useful last minute designs to throw in.
Yeah, tapes and potting compounds too. Potting compounds are definitely something we help with a lot. Tobias, I'm curious, you're a bit of a display expert. What do you think this other connector is over on the right?
Ooh, that is a great question. I would first pose that to the audience, because it seems like we have some experts there. My guess looking at this is if it's an LCD, and again, we did try to rip this apart to actually look at some of the layers. If it's an LCD, there's likely a backlight layer with a reflector, and then the actual panel. And sometimes that's all integrated into one flex cable. But the only other thing I could think of is if this was separately powering the backlight, and this was actually split into a kind of a multi-layer display here, because I don't think there's any other signals going through. I don't think there's any other sensors. I don't think there's an antenna around here. So that's my best guess, but it's not something I typically see of kind of a side connector here. So I'm not sure why it wouldn't route through the main flex, but would love to hear from the experts. You guys have any thoughts on what that is?
I think you're right. I think that makes sense to be a backlight flex, and it's on there because it's basically inaccessible once you put this down. So that's probably how they attach it into the main flex. And then it looks like they have yet another flex that they use another ZIF connector and then wrap it around, just because routing all of that and having it all be one flex would probably cost a lot. And then if any one component failed, it'd be hard to take that apart. So I think that makes sense, because it looks like maybe 6 or 5 or 6 pins. Can't get too many signals in there.
Yep. Interesting that they have this shielding tape though. I'm taking that off here. Originally I thought that might be something conductive tape for RF shielding, but looking at it now, I don't think it's actually conductive. It could actually be just to keep that flex from sticking out and hitting on anything while it's actuating side to side.
Yeah.
All right, the display here, and then what do you guys think? What's the purpose of this extra little flex here? It looks like they've got a ZIF, which is then into just like a little interposer flex that does a little 90-degree jog. Why didn't they just make this all into one giant flex that curves that way?
Yeah, panelization comes to mind for me. I know we've done some like folded flex, like a 45-degree fold. That looks similar. I don't know, Chris, other thoughts you have?
Yeah, I think that's a great idea, is panelization. Also, the movement, because you need it to go in and out. So as it's moving, you need something that can take up the slack. So maybe that second flex, can be, looks like it's almost like heat stake down. Can also have an anchor point while it moves. And if you had a single flex do that, then it would like kind of bend in a different way.
Totally. Yeah, I could see that
Yeah.
causing some bad things. Yeah.
All right. we're almost at time here. So last chance to get your questions in. We can talk about this lens, and we can go back and revisit if there's anything really specific you want to discuss. We got just a couple minutes. If you are in a time crunch, you need to hop off, please make sure to fill out that survey before the end, because that'll tell us what we're going to tear down next. And looks like final questions around the lens assembly. I've got some guesses. I know a little bit about lenses from my Apple Watch days working on the optics on the back. Do you guys know, does anyone lens this is here?
Well, it's got a lot of striations in it, so it must be, I don't know, is that a Fresnel? Is that a Fresnel lens?
I'm thinking it has to be. Looks like Marco is guessing Fresnel as well. I think just because of the space constraints, I think it's got to be a Fresnel lens. It's actually a fascinating topic for anyone that's not familiar with Fresnel lenses. I would suggest going to read up. It's essentially, if you take a standard like hemispherical lens and then slice it up into concentric rings and then squash it down in Z height, you have the same lens profile, but a very slim Z profile. And so I think that's what they're doing here, because again, the space constraints, they don't want to take up a ton of space. And I think it's a clever design. I think it's standard in a lot of the VR headsets these days.
Does that not interfere with the optical quality? Is it, you can basically, just because I always think of like little steps in the lens that you'd start to see that, but I guess is your eye not able to do that at such a short distance? Or
it's we could have a whole change notice on Fresnel lenses. Maybe that'll be the next one. Everyone fill out the survey, vote for Fresnel lenses if you want us to spend a whole session on Fresnel lenses. The key parameter when you're slicing it up, again, this is probably molded, is how sharp you can get the edge peaks. So if they're infinitely sharp, then there's no loss in optical quality. Obviously, that's not possible when you're actually molding. So as those tips get rounded, that's where the optical quality takes a hit.
Got it. And I want to share just briefly the last thing I want to say. This is like the controller, just because I think people are kind of interested. You're in VR, but how do you like move around? So this is their controller, very similar to some of the other things. There's like but you can see they have all these little spots on the outside. And so if I take off this cover, if I can get it out, you can kind of make out there's a bunch of like little LEDs here. So they must be doing something with tracking to work on this controller. But that's another interesting thing when you're making a gaming system. You need to figure out how to move in space. So I thought that was kind of fascinating.
Cool. All right. Well, I wish we had time to go into the controller too, because that looks pretty neat. But we are right at the top of the hour. I know everyone needs to rush off to the next meeting. So first and foremost, thank you guys for joining. Thank you for posting your questions. This was a lot of fun. Few reminders. Please fill out that survey. Tell us what to tear down next. We actually do read that, and that's how we decide what to tear down. If you're a mechanical engineer and you want to get in on the fun, let us know. We're looking for other people to come join in on these teardowns. And if you want access to all the teardown library that we're going through, also please let us know. You can also reach out, communications@Instrumental, and we can make that happen. We can also show you a little more on instrumental capability if you're interested about how that test data and how some of the correlations work. And if you missed it, we also had a half-day virtual event, Build Better, just a couple of weeks ago with some fantastic content. And that is all going to be available in video format. So I think we can post the link in the comments here. But if you're just itching to get some more some more instrumental hosted content. A lot of great guest speakers there. So thank you guys so much. We will see you next time. Thank you to Chris and Molly. See everyone next time.
Take care.
Bye, everyone. Thank you.
Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich, remote dataset to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today.